بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Welcome my dear students in third preparatory grade. We'll answer the second and the lastest part of the question on lesson 2. We will answer the questions about the graphs, many graphs. Question number 14. Study the following graphs, then answer. What is the horizontal axis and the vertical axis represent the following figures? This is the horizontally axis, this is the vertically axis, okay? This graph represents the speed equals 0. Speed equals 0 when the straight line parallel with the time, okay? So the velocity or the speed is constant. Speed equals 0, so the object is in a static state, in a static state. So the speed equals 0, so the distance doesn't change by passing the time. The time will pass without any change in the distance. Okay, so the axes are distance and time. The second graph represent motion for a body with irregular speed. Irregular speed, it's represented by the distance and the time. Okay, the distance is changed by passing the time, so it's represented by a curved line. Question number 3 or graph number 3, acceleration equals 0. Acceleration equals 0, it's meaning that V2 equals V1. So V2 minus V1 equals 0. So the acceleration equals 0 when the object moves by regular speed or uniform speed, constant speed, they are equals. Okay, the velocity or the speed on the vertically axis and the time in the horizontally axis. So the relation between velocity or the speed and the time, it represents by regular or parallel straight line with time, so the acceleration equals 0. The following question number 2 about graphs also. Okay, question number 2, describe the motion of the body in each of the following graphs. Okay. Describe the motion of the body in each of the following graphs. The first, distance. This is the relation between distance and the time, and the distance doesn't change by passing the time, so the object is in static state. This is a static state. So the velocity equals 0, or velocity equals 0. This object doesn't change or doesn't move, okay? It doesn't change its position. Figure B, the relation between speed and time. Speed and time, this is the inversely proportional, so the speed decreases by passing the time. So this is the object moves by acceleration, but it's a negative acceleration. Negative acceleration, okay? Negative, why? Because the V2 equals 0 and V1 more than V2. The following graph represents the relation between speed and time. This is the two relations, okay, two relations. The first, the speed of the object is increasing by passing the time at the first period, and the second period, the speed is B constant. So this object moves by positive acceleration at the first of motion, then it moves by uniform speed. Uniform speed, it's meaning that the acceleration equals 0. So the first part represents the object moves by a positive acceleration, and the second, the acceleration equals 0. The following graph D, okay, represented by distance and time, and this is the straight line passing by the origin point, so this object moves by uniform speed. Uniform speed, it's meaning that the acceleration equals 0. The following graph E, the speed and time. Speed increases by passing the time, so this object moves by positive acceleration. The following graph F, the relation between speed and time. Speed is constant by passing the time, so this object moves by uniform speed. This is the uniform speed. Uniform speed can be represented by two graphs. The first between the speed, the relation between speed and time, and the relation between distance and time. When the relation between distance and time, this is the uniform straight line passing by the origin point. But the second, the relation between speed and time. So this object moves by uniform speed, then the speed doesn't change, so the straight line parallel with the time axis. Okay. Question number 3. Which of the following graphs represent the movement of an object at? Okay, we can choose from A, B, C, D by 1, 2, 3, and 4. Number 1, an increasing acceleration. Increasing acceleration, it's meaning positive acceleration. So the speed increases by passing the time. So the relation between speed and time, positive acceleration or increasing acceleration, the speed increases by passing the time. Okay, so number 1 with A or graph A. This is the first. The second, deceleration or decreasing acceleration. It's called a deceleration also. Okay, deceleration or decreasing acceleration, the relation between speed and time. Okay, the graph B or C. Then the speed decreases by passing the time. The time increases, but the speed decreases. So the relation between speed and time is inversely proportional. So C with number 2. Okay. Question number 3. A zero acceleration. When the object moves by zero acceleration, this means the speed is constant, uniform speed, regular speed. So we will search about the speed and time. It's uniform speed or constant speed. Okay, it's meaning zero acceleration. So figure B or graph B with 3. Rest. Okay, number 4. This is the remaining. D, remaining. Okay, we will show by that. Okay, distance and time. Distance parallel, so the distance doesn't change by passing the time. So D with 4. The following question. Number 4. From the two following graphs, determine the first graph 1. Okay, the relation between distance and time. Okay, from A to B, then from B to C. The following graph 2, from the relation between speed and time. Okay, x, y, and y, z. Okay, we will choose or read the question about these graphs. Number 1, the time intervals during which the body moves at uniform speed in the two graphs. Okay, we will search about the time intervals during which the body moves at uniform speed. Uniform speed, when we form a relation between distance and time, so it represented by straight line passing by the origin point, so the distance AB. Okay, AB, this is the first graph, and in B2 graph or graph 2, okay, the constant speed or regular speed, uniform speed, it's parallel, so this period from Y to Z. Question 2. The time interval during which the body moves at a uniform acceleration. Uniform acceleration, it's meaning the speed of the object change. The speed of the object increases or decreases. So the relation or the period xy, it represents the uniform acceleration, xy. Okay. Question number 3. The time interval during which the body is at rest. At rest, so the distance doesn't change by passing the time. This is the period BC or the line BC. We can calculate the time. Okay. AB unit 2, 3. Okay. This is the 3 units. 3 seconds. Okay, if we thought that the square equal unit, okay, or equal second. The second graph YZ from Y to Z, square 2, 3, 4, so it's 4 units or 4 seconds. The time intervals, okay, xy from x to y, square 2, 3, so it's equal 3 units or seconds. Question number 3. The time intervals during which the body is at rest. At rest, BC, from B to C, okay. Walk square 2, 3, 4 seconds or 4 units according to the square represent, okay. Problems, we will choose many of problems. We can't answer all the problems, okay. If you need any question or any problem, you can write it, okay, in your comments. Question number 2. A car moves from rest and its speed reaches 25 meters per second in 10 seconds. Calculate the acceleration. What is the type of this acceleration? At the first, we can determine what he gave which in this problem. A car moves from rest. From rest, it's meaning V1 equals 0. Its speed reaches 25 meters per second, so V2 equals 25 meters per second in 10 seconds, so this is the time. Calculate the acceleration. We can apply our rule. It's very easy, okay. It's directly applying. Acceleration equal V2 minus V1 divided time. V2 equals 25 minus 0, okay, divided time, it's equal 10. So the acceleration 2.5 meters per second square this is the measuring unit of the acceleration. What is the type of this acceleration? We have two types of acceleration, positive or negative. This is positive acceleration because V2 more than V1, okay. This is the second question. The following question number 3. Question number 3. A special car can move from rest. From rest, it's meaning that the V equal 1, V1 equal 0, V1 equals 0. And its speed reaches 90 meters per second. So the speed reaches to, so the final velocity V2 equals 90 meters per second in 10 seconds. This is the time equals 10 seconds. What is the acceleration at which the car moved? Acceleration equal delta V divided delta T. It's equal V2 minus V1 divided time. It's equal 90 minus 0 over 10. It's equal 9 meters per second square. This is question number 3. This is question number 2.